Thank you. Hi everyone. For those of you that don't know me, my name is Neal. I've been coming to these meetups for about 4 or 5 months now, and the first meetup that I went to was actually Casper's Rabbit talk. So after that I was quite inspired by it. I was keen to find an application for it at work, so we gave it a go as soon as we could find a use case for it. And then, a little bit foolishly, but also because I was quite eager, I tweeted this after a Redis presentation, which then prompted Casper to get in touch with me and say, hey, would you mind coming in and talking about your experiences with Rabbit? Which is why, for the first talk of the first meetup of 2015, I'm stood here talking about not Symfony in a Symfony meetup. So before we begin, here's the slide about me. So I'm a PHP developer. I've been using Symfony since about 2011. I run the Twitter product for a major advertising API partner. And in my spare time, what spare time I have, I'm studying physics at the Open University. And I mainly tweet about science, nature and development. And of course, there's my Twitter handle up there if anybody wants to follow me. So first of all, I'm going to give you the background of our implementation, why we needed to use Rabbit, and how our system has evolved from the very first kind of queuing system that we had to what we have now. So first of all, as I say, we are a major social media ads API consumer. We potentially make thousands of API calls per hour, at least thousands of API calls per day. We needed to find a scalable solution because our current situation wasn't working for us at all. So we needed to find something that was more scalable, easier to extend than what we had previously. And we're going to go through that now. So the first generation of our evolution was simply having cron jobs running every minute to select X amount of rows from the database to send to APIs. Crons are running Symfony tasks. Each of those perform exactly one job. We've got a sync process spawning multiple call requests to localhost, which is a bit of a problem. Which we'll get back to in a moment as well. I'll explain why that's a problem for us. But ultimately, what we're doing is sending requests back to the same server to fire off multiple call requests and multiple API calls all at once. And we've got a lot of Symfony tasks running every minute. In fact, it's 120 crons, each running every minute. And a lot of the time, they don't actually do anything. They're just making database calls on the database instance and returning empty result sets. There's no real need for them at all. So they're kind of redundant, which we don't want happening really. And so we're just going to focus on a small part of our app today, which is the syncing and the ad creation that we've got going on and why we need to queue these properly. So we've got an example here of the first generation of queuing system. We've just selected columns from the adverts table where the update flag is U for update. Problems with this approach is that we're relying on selecting what we feel we can get away with within a minute, which isn't very many at all, obviously because we don't want to send the same rows twice to the API and start incurring extra charges for our clients with Facebook. We might only be selecting a few rows, but we need to select from hundreds of thousands in the table. So of course, sort of row by row checking, that's going to be quite slow if we're only selecting 20 rows at a time. And every minute we've got a massive data read spike on the database and on the web server CPU, because the web server is running these cron tasks. We don't have a dedicated instance running these tasks at the minute. And the data comparison is performed on a non-indexed column. So we could quite easily add indexes to some of these columns and speed things up, but at the moment we haven't. And the sync process that I told you about, where we fire off crons where we fire off API calls to our own server, actually ends up fault bombing the server, and it becomes unresponsive until we reboot it, which means then that the clients don't have anything to log into until we've rebooted. So the second attempt that we had at this, the second generation, it's a clever one. We've just got a queue table where we inner join the adverts on. Again, the same. So the queue table actually just shrinks and grows with the number of items that are being queued. It's got a few benefits to it. We're selecting from fewer rows to start with, so it is a little bit faster. We haven't benchmarked it, but we do have indexes on this as well, so it is a bit quicker. Problems with that is we can still only select a certain amount per minute. We have to guess at what we think we can get away with, the same with the first generation of the queue, and we still get a big data read spike. And as well, the complexity increases with this, because then we end up with a queue table for sending stuff to the API, and we end up with a queue table. Sometimes what you want to send to the API is different to what you're reading, and you need to select different data from different tables. And we ended up with 13 different tables just to try and queue API reads and writes. And here's a bunch of them here. So we end up with, for example, if we wanted to sync tweets from the API, we've got a sync progress table, which is then joined to the promoted tweets table, which is then joined to our actual tweets. So these are selecting advert tweets from Twitter. Same with targeting. We join the sync table to the targeting table, and then to the actual table which holds the targeting. And it just becomes a bit of a mess for trying to do anything when you're selecting from the API. So, the code as well becomes a little bit messy. So we've got here, on a campaign for instance, we've got this queue method which sets up an instance of the Twitter queue here, and you can see we're just doing CRUD here. Inside that, we've got here the method. You can notice here as well, we have to pass in what column we want to join on. So it's coupling the database to the code a little bit too much within this queue system. And then finally within here, you can see this is the column that we've just passed in, and we have to mess about with detecting if the queue exists. Don't bother creating it, we just return it. If it doesn't exist, then we make a new version of the queue and return that. So everything's a little bit messy, and it's not a maintainable solution. So inside the tasks as well, what we've got is, you can see here, so we're fetching X campaigns from the database, which we've already been through. And then inside that, we're going to fetch the access tokens from the database for each row, send it to the API, and then save the response back to the database. Again, we've just got a hell of a lot of noise to the on the network and going to and from the database. And a quick flowchart here, you can see the user saves their stuff into the database. Later on, our task picks up the information, loops through all the rows. For each row, we're fetching the access token here, making the API call, saving the result, and just looping through here. There's a hell of a lot of noise going on there, which we want to get rid of. And then finally, we finish what's happened there. So obviously, this is kind of slow. This is the reason that we needed to find something else to do. So hence, we chose Rabbit. And we'll just quickly go through what happens with Rabbit. We have a producer which sends a message to Rabbit. So the Rabbit will be in your application code. It could be in a doctrine hook or anything like that. Rabbit then saves the message, queues the message up, and the consumer does the actual work later on. You can see here the code is a little bit tidier here. Instead of having this method in the middle to return a queue instance, we've now got just queue, and then we're using HTTP methods here. So drop CRUD, there's no point for that. We're just going to use this. Here you can see this is just a little bit nicer inside, because now we can just pass the access token straight into the message that we're sending Rabbit. Again, there's no need now to actually select it from the database for each row that we've got. And then in here, this is just setting up a Rabbit connection, nice and simple. You can see the queue name here, which using the different queues means that you can perform different tasks really easily and keep everything nice and separate. The consumer can be written in any language. We decided to have a look around, see what was available. Choose something fast is what we came up with. There's no point spending time implementing Rabbit to then choose a really slow consumer that's not going to actually give you any kind of benefits. So what we thought about was YOLO with Guzzle and Eloquent ORM there. We decided against that. We've got some so we've got a lot of our services are being run with Node.js. So we decided to go with Node and Sequelize. Sequelize being the doctrine equivalent ORM for Node. So that's why we went with Node. In that, I'm not going to go into Node, don't worry. So the benefits of this is that we've now got a dedicated instance running Node and performing these tasks. So we've taken the queue processing even off the web server, so the client doesn't see that drop in performance every so often when we're trying to send stuff to the API. We've reduced the number of database calls. We're continually processing queues, so we don't have to worry about can we select this amount and process them within a minute before the cron runs again, etc., etc. And we've got a much more simplified architecture. So this is the new flowchart that we've got. You can see here, user saves campaigns. We send, at the same time as sending everything to the database, we also send everything to Rabbit. The consumer runs, makes the API call. Is it successful? Yes, save the result back to the database. We've got rid of, if we compare to the previous one, we've got rid of everything here, so we've achieved that goal. We go back to here as well, so you can see if the API call wasn't successful, we can send it back to Rabbit. Now that's one of the things that we had most difficulty with, was working out how to send how to requeue in Rabbit, because Rabbit doesn't have an actual requeue method, which surprised us because we thought it would. And there are many different suggestions on the internet of how to achieve it, but that brings us on to requeuing messages. So the way that we decided to requeue messages when there wasn't a successful call was by using something called the dead letter exchange, which just basically means we've got QA, which is our primary queue. The consumer pulls messages from here, makes your API call. If it's not successful, we then put the message back into another queue called QB, in this example, with a couple of extra fields here. So we've got dead letter exchange points back to QA, and we've got a TTL on that message. So nothing actually pulls anything from this queue whatsoever. And that TTL of 900,000 there is just 15 minutes. It's in milliseconds, so it's 15 minutes in that message. So nothing actually consumes from here at all. And once the TTL expires, it goes back into QA, and then the consumer picks it up and we do the whole thing again, and hopefully next time it will be successful and we're done.
How does it go from QB to QA?
Rabbit, just once the TTL expires, Rabbit takes the, if I go back to here, the dead letter exchange that we've passed in, Rabbit will take and put it back into QA. It knows to put it back into QA where the consumer is going to pick it up again. So the good points of what we've done is straight away we've removed 13 different crons, so that's always a bonus. We're continually processing the queues. We don't have to, as I say, we don't have to be waiting a minute for everything to process and then picking up another bunch. Everything happens pretty much in real time. We've moved the load away from the client-facing servers. We've reduced complexity, and everything is much faster. I've got some graphs at the end to show you as well with that. Bad points, because we chose Sequelize, we've had to remodel everything in Sequelize as well as in Doctrine. So that, first of all, slowed us down learning how to use Sequelize. Second of all, yeah, we've now got to maintain the database model in two places, which is a bit of a nightmare, and we haven't yet decided how to tackle that. So these are a couple of graphs that I did today with, I was benchmarking our old system with the new system, and you can see here that we've got one large account synchronization that I ran, which took about 6 hours on the old method of doing it as a huge account, and it took 13 minutes, I think, to do it using Rabbit. So we've gone from over 6 hours to 13 minutes, and then down here we had a couple that took about 4 or 5 minutes where they were taking half hour previously. So that's really, really sort of sped things up, which means our clients are going to be happier as well. So that's the actual time taken. The next slide here is actually the amount of time that we save. So you can see the longer the original queue would have taken, the more time that we save, which I think is kind of self-explanatory really anyway. With that, so what's next for us? We're going to implement Rabbit queues for campaign creation on the Twitter side. We haven't quite done that with Twitter yet. We want to do it for Facebook because it's the Facebook sync which is the one that we're fork bombing ourselves with, so that's going to be a major kind of plus point for us. And then finally, we've already built our iAds implementation directly on top of Rabbit. We haven't bothered with anything else. We've built that in Node with Rabbit, and that's working fantastic. So there we go, that's me once again for all you guys that want to follow me, and you might have worked out my age by now with that at the end. So are there any questions at all? If there are no questions, it either means that nobody's been listening or I've done a really good presentation. I think it's probably not the latter. Everyone,
when
yeah?
you need access to the model and the clients, like in the consumers.
In the consumer, yes. So
Why do you need access to the database and the consumer?
because we're saving data back from the API, so it might be, so if we're fetching like tweets from the API, we need to obviously save those tweets or promoted tweets, which is a tweet linked to an account, and an advert and everything else with bidding and budgeting, everything attached to it. So that's why we need to save data back. If we could have got away with not remodeling it, that would have been great, and things would have been even faster for us, and we could have sort of launched that about a month earlier than we did, but unfortunately not. Go on.
Are you considering, seeing as you have SQLize and Doctrine, that
Yep.
at some point you'll use Rabbit internally to sort of also replace either Doctrine or SQLize, so you've only got one model and just sort of JSON encoding them and sending them down so you don't...
Yeah, of course, yeah. So that would be, I've been sort of putting some thoughts to this today. That would obviously be preferable to only be maintaining that in one place. And perhaps the way to do it would be move everything to Node and then access via an API from the PHP side.
Have you considered using Rabbit not just as a queue but also as a mechanism of actually results, sending and receiving result sets?
Not yet, no. But I might have a think about that, yeah. So, go on, yep.
So do you think that the Node.js is really like beneficial from PHP? Because we use Rabbit and Q with Symfony and it just works?
Yeah, well, for us it has been, yeah. Because we've got a few legacy parts of our app which we're trying to sort of drag up to the 21st century. So for us, yeah, it's been really good. It's definitely sped a few things right up for us. So, yeah. Go on.
Looking further into the future than next week,
Yes.
do you use Rabbit as data storage or just for events? I have an event with a really long lifespan and just leave it in there and read it and then put it back in again?
I don't know. I've got to be honest, I don't know. Presumably you could, but I don't know why you'd want to.
So you get rid of the database?
Yeah. But it might be better to look at other things in that case. I don't know. I'm not... Yeah. Presumably it's possible, I don't know. I mean, in theory you can have unlimited channels, unlimited queues in Rabbit from what I've read. So perhaps you could have an unlimited TTL on something or whatever and just never consume it. But I don't know. It's if that instance gets switched off for whatever reason, you might lose everything that you've had. So, yeah. Yeah. So,
is there any particular reason for you to choose Node.js other than using other things like Golang?
say again, sorry, I didn't catch that.
Any particular reason you chose to use Node.js other than like Golang?
Yeah, well, we've got a developer in our company who loves Node, and he's come in and he's implemented a bunch of batch API stuff in Node, and we just thought it was natural to continue on that front because we've already got a Node instance running this stuff. So we built on top of what he'd already built. So, any other questions? Go on in.
So, what company do you work for? What do they do?
I work for Upcast Social, and we are a social media ads API partner. So we give advertising agencies the ability, a tool to bulk upload campaigns to Facebook and Twitter and iAds as well now. So the Twitter and Facebook tools might allow you to manage maybe 500 campaigns at once. We can let you do 6,000 campaigns all at once in our interface. Right, I think that's it. So I'm going to hand over presumably to Michael now.